We now determine the open intervals in which the graph of f of x is concave upward and concave downward. So to determine the intervals of concave upward or concave downward, we should find the second derivative of f of x. So let's find the first derivative of f of x. That is, we differentiate f of x with respect to x, and here we have to use the quotient rule of differentiation to find the derivative of this rational expression. So I put this denominator expression first and then multiply this with the derivative of the numerator expression, that is the derivative of 2x squared, and this equals, we put this 2, the derivative of x squared is 2x using the power rule, so it is 4x. Now according to the quotient rule we put minus. Now we put the numerator expression, that is 2x squared, multiply with the derivative of 3x squared plus 1, the derivative of 3x squared plus 1, and this equals 3 times of the derivative of x squared is 2x, the derivative of 1, which is a constant, is 0, so it is 6x. So I put 6x here, and this is over the square of the denominator expression, that is 3x squared plus 1 quantity squared. Let's simplify this. And so this gives, let's distribute the 4x. 4x times 3x squared is 12x cubed, plus 4x times 1 is 4x, minus this one is 6x times 2x squared is 12x cubed, and this is over 3x squared plus 1 quantity squared. We see that this 12x squared, negative 12x squared, they get cancelled, leaving us only 4x divided by 3x squared plus 1 quantity squared. So this is the first derivative of the function f of x. Now let's find the second derivative of f of x. So we differentiate this f prime of x on both sides. We will have f double prime of x, which is the second derivative of f of x, and this equals, once again we use the quotient rule of differentiation. So first I write the denominator expression, that is 3x squared plus 1 quantity squared, and then multiply with the derivative of 4x. The derivative of 4x is 4, and then I put the minus according to the quotient rule of derivatives. Now I write the numerator expression, that is 4x, and then multiply with the derivative of 3x squared plus 1 quantity squared, that is 3x squared plus 1 quantity square. We should find its derivative. So first we apply the power rule, because it is raised to the power of 2. We put the power 2 and then write the expression 3x squared plus 1 raised to the power of 2 minus 1, which is 1, so we can just ignore that. Then applying the chain rule, we multiply with the derivative of 3x squared, which is 6x. And so this basically gives 2 times 6x is 12x times of 3x squared plus 1. And so this is the derivative of this expression. Let's multiply. I write down 12x times of 3x squared plus 1, and this is divided by the square of the denominator expression, that is 3x squared plus 1. We already have a square, so when we square it one more time, it will become raised to the power of 4. Let's simplify this. So here we have f double prime of x. This is the second derivative of function f of x. Now we can see that we can factor this 3x squared plus 1 from both terms. So I'm going to factor 3x squared plus 1, and when I do that, here I'll be left with 1 factor of 3x squared plus 1 times 4. So I write 3x squared plus 1 times 4 minus, if I factor this expression, I'll be left with these two products, that is 4x times 12x, which is 48x squared. and this is over 3x squared plus 1 raised to the power of 4. Now we can simplify these two factors, that is, we can cancel with these powers. This will reduce to 3. Let's simplify this. So we have f double prime of x, and this equals, let's distribute this 4. This will become 12x squared plus 4 minus 48x squared divided by 3x squared plus 1 quantity cube. We can simplify this. So here it is f double prime of x, and so this equals, I put this 4 first, minus this is 12x squared minus 48x squared is negative 36x squared, and this is divided by 3x squared plus 1 quantity cube. And so this is the second derivative of the function f of x. Now using this, we are going to prepare the sign chart for second derivative so that we can determine the intervals of concave up and concave down. So for that, we have to set this up equal to 0. That is, f double prime of x equals 0 or undefined. This is not undefined for any values of x because the denominator will never be 0 because it is a quadratic expression, 3x squared plus 1 raised to the power of 3. So it's not going to be 0. So we consider only this equation, that is second derivative equals 0. And so when we do that, we get 0 equals 4 minus 36 x squared divided by 3x squared plus 1 quantity cube. And so we get 4 minus 36 x squared equals 0 when you multiply both sides by this denominator expression. Otherwise, 36 x squared equals 4, or x squared equals 4 by 36, which is 1 by 9. And when we take the square root, we get x equals plus or minus 1 by 3. So we get 2 points, that is x equal to 1 by 3 and x equal to negative 1 by 3. We now prepare a sign chart for the second derivative of the function f of x using the points x equal to plus or minus 1 by 3. So first let's create a number line, and we mark these points, that is negative 1 by 3 and positive 1 by 3. We should take some random points to the left and to the right of each of these points. So I'm going to consider x equal to negative 1, which is to the right of this x equal to negative 1 by 3. This is basically second sign chart for second derivative. When we plug it into the second derivative, here we have the second derivative, that is 4 minus 36x squared divided by 3x squared. This one is 3x squared plus 1 quantity cube. In fact, we can reduce this to only 4 minus 36x squared because this denominator expression is going to be always positive irrespective of any number, whether it is positive or negative number, because we have a square term. So this will be positive. 3 times positive number is positive, plus 1 is going to be positive, and cube will be positive. So you can just remove this for sample points. So we can consider only this expression, which will be easy for us to determine the sign. And so I'm going to put x equal to negative 1 into this expression. When I do that, I get 4 minus 36 times of negative 1 square. This equals 4 minus 36 times of 1, and this is less than 0. So the second derivative is negative to the left of x equal to negative 1 by 3. So let's mark this as negative. Now let's consider any random point between this interval x equal to negative 1 by 3 and 1 by 3. We can consider 0. So when you plug in 0, it becomes 4 minus 36 times of 0, and this is 4, which is greater than 0. So we mark positive in this interval. Now let's consider x equal to 1, which is to the right of x equal to 1 by 3. So we plug in x equal to 1, and when we do that, we get 4 minus 36 times of 1 squared. And this is once again going to be less than 0. So it is negative. So we mark this as a negative. And this means whenever the second derivative is less than 0, we see that it is a concave down interval. This is concave down. And here also it is concave down. And whenever the second derivative is positive, we see that it is concave up. So we can now write down the concave up and concave down interval using this sign chart of second derivative. First, we write concave up. The interval is negative 1/3 to 1/3. And let's write the concave down interval. The first one is negative infinity to negative 1 by 3 union 1 by 3 to positive infinity. And thus we have determined the concave up and concave down intervals.